What is a fullerene?
A fullerene is any molecule made up of only carbon atoms that has a shape of a sphere. Ellipsoid, a distorted sphere, or a tube. The name fullerene comes from Richard Buckminster Fuller, an architect who designed the geodesic dome. Spaceship Earth at Epcot Center is a geodesic dome. The U.S. Post Office recently commemorated Fuller and his geodesic dome on a stamp. Are just a few nanometers wide, but can be up to several millimeters long. The properties of this form of matter are almost unique in the world. And as a result, carbon nanotubes have caught the attention of many chemists. Nanotubes conduct heat and electricity very well, but are also extremely strong, specifically in tests of tensile strength.
What is a kinase?
Kinases are a class of enzyme that is responsible for transferring phosphate groups, see image below, from donor molecules, such as ATP, to substrates during a reaction called phosphorylation. These are typically named for their substrate, for example. A tyrosine kinase catalyzes the transfer of a phosphate group to a tyrosine residue of a protein. Kinases are part of a larger group of enzymes called phosphotransferases, all of which carry out chemistry involving phosphate groups, shown below.
What is the reaction order?
The number of chemical species simultaneously involved in a chemical reaction.
What is cooperativity?
Cooperativity describes how the binding affinity at one site of a protein affects the binding affinity at another site. In hemoglobin, for example, there are 4 sites at which oxygen molecules can bind. After the first oxygen molecule binds, conformational changes take place in the rest of the protein that increase the binding affinity at the other sites. The second oxygen is then able to bind even more easily, and the third and fourth even more easily yet. This gives rise to a sigmoidal curved shape in a plot of the fraction of hemoglobin bound by O2 versus the partial pressure of O2, see illustration. Similar binding curves result in other examples of cooperativity, though the example of hemoglobin is probably the most commonly discussed example of the phenomenon.
Why did Wilhelm Ostwald, Germany, win the Nobel Prize for Chemistry?
For his work on catalysis and for his investigations into the fundamental principles governing chemical equilibria and rates of reaction. Ostwald performed many experiments surrounding the strengths of acids and bases and was the first to carefully explore how reaction rates are affected by acid/base catalysis. He was actually the first to coin the term catalysis in the context of chemistry. And his definition of catalysis is still very much the same as the one used today. Ostwald's work corroborated earlier studies into acid/base chemistry by Arrhenius, and his measurement of chemical reaction rates under various acidic and basic conditions placed the understanding of Brønsted-Lowry acids and bases on a more sound footing. Ostwald also expanded the scope of his study beyond acid/base catalysis, and his work led to the understanding of chemical reaction rates as we know them today. He showed that chemical reaction rates did and the factors that influenced them did were quantitatively measurable parameters.
What is carbocation?
A cation in which a carbon atom bears a significant fraction of the positive charge.
What is a protein?
Proteins consist of one or more long chains of amino acids that fold up into a specific arrangement, and each is presumably capable of some kind of biological function. Though we don't know for sure that every protein has a biological function, the function of each protein is one thing many biochemists are still working hard to figure out. Some proteins act to protect an organism from invading pathogens. Some help to carry messages between different areas of the body. Some are responsible for movement of muscles, and some provide structural support for cells. Many proteins also fall into a class called enzymes, which is a name for proteins that catalyze specific chemical reactions in biological systems.
What are some of the worst nuclear disasters in history?
A few of the worst nuclear disasters in history are those which took place at 3 Mile Island in the USA in 1979, at Chernobyl in the Ukraine in 1986, and more recently following an earthquake in Fukushima, Japan, in 2011. Nuclear disasters are very dangerous if they do occur, and the possibility of a nuclear disaster represents a primary reason that some people oppose the construction of new nuclear power plants.
What is a cation?
A cation is a positively charged atom or molecule. Cations have a larger number of protons than electrons, such that they have a net positive charge.
Can wearing a copper bracelet help with the symptoms of arthritis?
Arthritis is caused by deterioration of the cartilage in a person's joints. Where deterioration happens faster than the body is able to repair it. Copper bracelets are sold based on the idea that a person may have a copper deficiency that leads to the pain in their joints, thus implying that copper from the bracelet could be absorbed through the skin to help correct the deficiency. In fact, copper deficiencies are extremely rare, and most people eat plenty of copper in their regular diet. Rarely are additional copper supplements necessary. It has not been proven that copper can be absorbed through the skin. Nor has it been proven that the bracelets can help with any symptoms of arthritis or joint pain. Moreover, excess intake of copper can result in poisoning. So if copper can be absorbed through the skin from a bracelet, one would want to monitor their dosage carefully. It is also worth pointing out that we know of no cases of poisoning resulting from wearing copper bracelets.
How does a microscope work?
A microscope is all about lenses. The lens near the sample you're looking at is called the objective lens. And this lens is responsible for collecting the light from the sample and focusing it. Typically there will be a light under or behind the sample that provides the light used to view the sample. At the other end is another lens called the ocular lens, and the total magnification of the microscope is determined by multiplying the magnification of the objective lens by that provided by the ocular lens. The apparatus we typically think of when we think of a microscope is essentially just a big framework used to hold the lenses, the sample, and perhaps other optical devices used to improve the image of the sample.
What is a bimolecular substitution reaction?
From the last answer, you can probably guess that a bimolecular substitution reaction has two molecules, molecular, in the transition state. This means that the slowest step involves two molecules interacting. In the previous example, there was only one. Let's look at a similar substitution reaction, but instead of T-buletin Cl, we'll react hydroxide with MeCl. Here the nucleophile, O, directly displaces the leaving group Cl, without forming a carbocation intermediate. This is because the methyl cation CH3 stable than the tert-butyl carbocation formed in the previous question.
What is an elimination reaction?
A reaction in which two ligands or substituents are removed from a molecule.
What is a chalcogen?
A chalcogen is an element in group 16 on the periodic table. This includes oxygen, sulfur, selenium, tellurium, polonium, and livermorium. This name comes from the Greek word meaning copper former, and has its origins in the fact that some of these elements tend to coordinate to metals to form compounds with metals in ores.
What is a photon?
A quantum, or particle, of electromagnetic radiation.
What is a glass transition?
Transition observed in amorphous materials between a hard material and a more liquid or rubber-like state.
Do pesticides make food more dangerous?
Pesticides certainly don't help make food safer, but their adverse long-term effects are difficult to measure. Limiting exposure as much as possible is certainly a good idea.
What analytical techniques are used in quality control for pharmaceuticals?
Some of the most commonly used analytical techniques in pharmaceutical quality control include infrared spectroscopy, UV/visible spectrophotometry, melting point determination, reactions based on color changes, and various types of chromatography, including thin-layer chromatography, high-performance liquid chromatography, and gas chromatography.
What happens chemically as stars age?
As stars age, they continually produce helium from hydrogen by fusion. So as time goes by, the amount of helium in a star increases and the amount of hydrogen decreases. In order to keep the fusion reaction going, stars heat up and get brighter as they age. Stars also continually give off a small portion of their mass, which generates solar, or stellar, wind. For our Sun, this is an exceedingly tiny amount of material, so don't worry about it vanishing anytime soon. Finally, stars slowly make elements heavier than helium as they age. This is typically quantified by reporting the ratio of iron to hydrogen in a star. Iron is not the most abundant of the heavier elements present in stars, but it is among the easiest of the heavier elements to detect.
What is a carbon-hydrogen bond activation reaction?
Carbon-hydrogen activation reactions are very much what the name would imply. They break typically unreactive carbon-hydrogen bonds. Considering the prevalence of carbon-hydrogen bonds in organic compounds, This is another extremely important type of reaction to be able to carry out both effectively and with selectivity. Successful examples of carbon-hydrogen bond activation reactions have only come about relatively recently, with the first genuine example reported ca. 1965, and organometallic reagents have played a key role in the development of carbon-hydrogen bond reactions.
Why did Max Ferdinand Peretz and Jean Caudery Kendrew, both United Kingdom, win the Nobel Prize for Chemistry?
For their studies of the structures of globular proteins. Peretz and Kendrew sought to elucidate the structures of large proteins using X-ray diffraction techniques, with a particular focus on hemoglobin and myoglobin. They took a variety of innovative approaches, including recording a huge number of X-ray diffractions, about 250,000, incorporating heavier gold or mercury atoms at well-defined locations into the molecule, and using a computer, one that was advanced for the time, to process the large amounts of data they collected. This was quite a challenging task, as even myoglobin, the smaller molecule of the pair, contains roughly 2,600 atoms. Their work was the first to help understand the principles behind the structure of globular proteins.
What is an organometallic complex?
These are molecules with bonds between carbon and a metal. This includes alkali and alkali earth metals, groups 1 and 2 of the periodic table, the transition metals. Groups 3 to 12, including the F block, and sometimes group 13 metals are also included. The bonds between metal and carbon can vary widely in their ionic or covalent character. The bonding between a metal and carbon is mostly ionic in two situations. 1. If the metal is very electropositive, as in groups 1 and 2, or 2. If the carbon group is a stable anion. By being delocalized via resonance as in cyclopentadienyl anion. There are also organometallic molecules with more covalent bonds between the metal atom and the carbon atom. This is usually seen with the transition metals or elements like aluminum. The nature of the metal-carbon bond plays an important role in how organometallic complexes react.
What is an aerosol?
Suspension of a solid or a liquid in a gas, e.g., smoke, fog.
Why should a chemist add acid to water and not the other way around?
This is an issue of safety. When an acid mixes with water, it will react very quickly. This reaction can release a large amount of heat and can cause the solution to bubble or splash. It's important to pour an acid into water, since acidic solutions are almost always more dense than pure water, meaning that the acidic solution will sink down into the water as it reacts. If you were to add water to a more dense acidic solution, the water would react at the surface of the solution, and there is a much greater chance it could bubble or splash up at you.
Is there water on other planets?
There is, though in most cases where water exists on other planets it does not exist predominantly in the liquid form, like here on Earth. On some planets there may be trace amounts of water vapor in the atmosphere. Beds of ice on a planet's surface, or superheated, ionized water near a planet's core. There may well be other planets out there with liquid water, but humans have not found many with large amounts of liquid water.
Why would a chemist want to measure conductivity?
Most practical applications of solution conductivity. Measurements involve determining the quality of water samples. Conductivity measurements can provide a measure of the total amount of dissolved solids in a water sample. This information can be put to use in different ways, depending on the context. But in general it provides a measurement of the purity of the water. Chemists sometimes use a method called ion chromatography, which is a type of liquid chromatography, LC. Ion chromatography often uses a detector that measures conductivity to detect when different analytes pass through the detector.
Why did Sir Robert Robinson, United Kingdom, win the Nobel Prize for Chemistry?
For his investigations on plant products of biological importance, especially the alkaloids. Robinson made significant advances in medicinal chemistry, both in synthesis and in gaining a better understanding of the mechanisms by which drugs work. His Nobel Prize was awarded for his work with alkaloids in particular, including quinine, cocaine, and atropine. Robinson studied and helped to understand how these types of molecules have their effects on the human body and mind.
What are a couple of examples of familiar chemical reactions?
Fire is one example of a chemical reaction that everyone has seen take place. Fire involves a combustion reaction, which is any reaction where a hydrocarbon reacts with oxygen to form carbon dioxide and water. Another example is when your car accumulates rust. This reaction involves oxidation of the iron in the metal. Lots of complicated chemical reactions are taking place all the time in our bodies too. Every movement you make, for example, involves many chemical reactions taking place in your muscles and nerves.
What is the signal-to-noise ratio in a measurement?
The signal-to-noise ratio is a comparison between the strength of a measured signal to the background variation naturally present in the experiment. There are different ways of reporting the signal-to-noise ratio, but one commonly used measure is to compare the mean value of a measurement to the standard deviation of the background region. For example, we might want to measure the intensity of a laser beam using a detector. The signal would be the measured intensity when we shine the laser beam on the detector. The noise would be measured as the standard deviation of the intensity measured. Due to the ambient light when the laser was not shined onto the detector. Such a definition is commonly used when looking at weak signals in imaging or microscopy. Choosing an appropriate way of reporting the signal-to-noise ratio can depend on details of the situation in question, such as whether the data can take on both positive and negative values, or whether the data can only have positive values.
Why did Walter Kohn, United States, win the Nobel Prize for Chemistry?
For his development of the density functional theory, and John A. Popel, United Kingdom, for his development of computational methods in quantum chemistry. Kohn and Popel represent two of the founding fathers of modern computational chemistry methods. Density functional theory is a method that relies on the function describing the spatial electron density in a molecule to calculate molecular properties. And Kohn was awarded the prize for his substantial contributions to the development of this now widely used approach. Popel also made major strides toward making computational methods reliable and accessible to a large number of chemists. In addition to his more technical achievements, Popel is responsible for developing the Gaussian computational chemistry software that is probably the most widely used computational chemistry tool available today.
How can I show my friends a magic trick using pepper?
Chemistry principles encountered in this experiment: polarity surface tension materials. You'll need a shaker or small packet of black pepper dishwashing soap, a few drops, bowl water, a bowl full. The procedure: begin by filling the bowl with water. Then pour black pepper onto the water to form a thin layer of pepper across its surface. As a control experiment, try dipping your finger below the surface of the water. Nothing too interesting should happen at this time. Now rub a small amount of dishwashing soap on your finger and dip it in the water again. This time, you should see the pepper move away from your finger and toward the edges of the bowl. The nonpolar soap molecules don't want to dissolve beneath the surface of the water, and thus they spread across the surface of the water quickly, which lowers its surface tension. Whereas water typically bulges a bit above its surface due to its relatively high surface tension. The water spreads out when its surface tension is lowered. This causes the water to spread out as the soap moves over it, and the pepper is carried away from your finger in the process. Now that you understand the basics of this trick, you can perform it for your friends. Ask a friend to dip their finger in the water and to try to concentrate on trying to make the pepper move away from their finger. When they cannot make it happen, you can step in and use your already soapy finger to easily move the pepper away.
What is a critical point?
A critical point is a combination of temperature and pressure, values above which a phase boundary no longer exists. There are liquid-liquid critical points above which the two liquid phases become miscible, and also liquid-gas critical points above which the boundary between the liquid and gas phases disappears and the substance becomes supercritical.
What about cis and trans fats?
The carbon-carbon double bonds along the hydrocarbon chain of fatty acids can be either the cis or trans isomers. Naturally occurring unsaturated fats have more cis fats, while man-made fats, like margarine, have a higher level of trans fats. Trans unsaturated fats turn out to be particularly bad for humans as they increase cholesterol, leading to heart disease.
What was the law of octaves?
The law of octaves was put forth by the British chemist John Newlands. He noticed that, when the elements were listed in order of increasing atomic weight, elements with similar properties occurred every 8 elements. The trend was named the law of octaves by analogy to musical scales, and it was the first realization of the relationship between atomic masses and a repeating pattern of elemental properties. This periodicity has since been explained in detail as chemists have gained a better understanding of atomic structure. And the law of octaves played a crucial role in the development of the periodic table chemists use today.
How fast does light travel?
In a vacuum, the speed of light is about 3 × 108 meters per second, which is very fast. That's so fast that a beam of light could travel around the whole world in only about 0.13 seconds. It's interesting to consider just how far away from the Earth stars really are. After the Sun, the next closest star to the Earth is over 4 light-years away. A light-year is the distance light travels in 1 year. This means the next closest star is over 20 trillion miles away. Because light must reach our eyes for us to see anything, if that star exploded, we wouldn't see it until over 4 years after it actually happened.
What is density?
Mass per unit volume of a given substance.
How do instant noodles cook so fast?
Because they're already cooked. Instant noodles were invented in Japan in the year 1958 by Momofuku Ando, who was working at Nissin Foods. The noodles are flash fried, creating a dry noodle with a very long shelf life that can be prepared in minutes.
What is a chemiluminescence?
Emission of light resulting from a chemical reaction.
Why do hard-boiled egg yolks turn green?
When egg whites cook, a small amount of hydrogen sulfide, H2S, is released from sulfur-containing amino acids like cysteine or methionine. If the H2S migrates to the yolk, it combines with iron atoms to produce ferrous sulfide. FeS, which is a dark-colored material that looks green mixed with the bright yellow yolk. Ferric sulfide, Fe2S3, is also sometimes claimed to be formed in this process. Likely because it is itself a yellow-green substance. There is, however, less data to back this up, aside from the convenient color match.
What is a catalyst for a reaction?
A catalyst for a chemical reaction is any chemical species that lowers the amount of free energy necessary to achieve the chemical transformation. This may involve a significant change in the mechanism by which the reaction takes place. Light may also serve as the catalyst.
What is the earliest historical evidence of the study of chemistry?
Although they didn't call it chemistry, people from ancient civilizations used chemical reactions in many aspects of their lives. Metalworking, including the extraction of pure metals from ores, and then combining metals to make alloys. Like bronze, left many artifacts of early man's chemistry experiments. pottery, including the production and use of various glazes. Fermentation to make beer and wine, and pigments and dyes for cloth and cosmetics are all evidence that man has always been fascinated by the ability to change matter.
What pollutants are introduced into the atmosphere by volcanoes?
Volcanoes are a major source of sulfur dioxide, SO2, gas in the atmosphere. This gas is poisonous and is an irritant to the mucous membranes found in your throat, eyes, and nose. Sulfur dioxide also reacts with oxygen, sunlight, dust, and water to create SO2 droplets and sulfuric acid, H2SO4, which leads to a type of smog referred to as volcanic smog, or VOG. VOG can cause asthma attacks and damage the upper respiratory tract. The sulfuric acid produced can also cause acid rain.
What is diffusion?
Diffusion is essentially the random motion of molecules, or atoms, through a medium. It causes the concentrations of species in a liquid or gas to even out across the accessible volume. Diffusive motions of molecules in a liquid or gas are typically responsible for the chance encounters that lead to bimolecular reactions.
How many stars are in our galaxy?
Astronomers currently believe that our galaxy, the Milky Way, contains between 200 billion and 400 billion stars.
What is the difference between eukaryotes and prokaryotes?
Prokaryotes are organisms whose cells do not have a nucleus, while eukaryotes are organisms whose cells do have a nucleus. Prokaryotes are most often, but not exclusively, unicellular, single-celled organisms. In addition to lacking a nucleus, they also lack other separate membrane-bound organelles. All of the proteins, DNA, and other molecules in a prokaryotic cell float around within the cell membrane but are not separated into different compartments. Eukaryotes do typically have separate membrane-bound organelles within their cells. They may be single-celled or multicellular organisms. Every large organism, animals, plants, fungi, is eukaryotic, and many small and single-celled organisms are in this category as well.
What makes wine taste dry?
The dry taste certainly doesn't fall into one of the 5 basic groups, but it is known to be related to the presence of tannins.
What is the biggest laser in the world?
The largest laser in the world is located at the Lawrence Livermore National Laboratory in Livermore, California. This laser is so large that it covers the size of 3 football fields. The scientists who use this giant laser for their research are hoping to show that a nuclear fusion reaction, see nuclear chemistry, can be controlled and used as a source of energy. If that's possible, it could revolutionize the way power plants make energy.
What is an aliquot?
A sample taken from a larger amount of a material.
What prevents all of the air from escaping Earth's atmosphere?
Gravity. Every molecule on Earth is pulled toward the planet by gravity, even the very lightest gas molecules. To overcome a planet's gravitational pull, an object, be it a spaceship or a helium atom, must reach at least the escape velocity. Almost all of the molecules in the atmosphere are below this velocity because of the temperature of the planet Earth. Higher temperature equals faster molecules. Almost all? Yes. Earth is very slowly losing its atmospheric gases. The lightest ones go first. About 3 kilograms of H2 escape the gravitational pull of Earth per year. A few particles can escape because kinetic energy of gases is a Boltzmann distribution. And in a Boltzmann distribution there are always very small probabilities of very high values.
What is saponification?
Saponification is a type of reaction in which the ester functional groups of triglycerides are hydrolyzed under basic conditions. The term can also refer to the hydrolysis of any ester as well.
What is a decant?
To pour off a liquid from a solid sediment.
Which elements are liquids at room temperature?
Actually there are only 2 elements that are liquids at room temperature, mercury and bromine. Bromine is a diatomic compound, Br2, while mercury is a liquid metal.
Why did Dudley R. Hirschbach, United States, UNT Lee, United States, and John C. Polanyi, Canada/Hungary, win the Nobel Prize for Chemistry?
for their contributions concerning the dynamics of chemical elementary processes. Hirschbach was recognized for having developed the method of using crossed molecular beams to carry out detailed studies of chemical dynamics. Lee was initially working with Hirschbach, and independently further developed the method of using crossed molecular beams to study important reactions of relatively large molecules. Polanyi developed the method of using chemiluminescence in the infrared where weak infrared emissions from recently formed molecules is measured to learn how energy is released during chemical reactions. Why did Donald J. Cram? United States, Jean-Marie Lane, France, and Charles J.
What is a phase diagram?
A phase diagram shows the phases of a particular substance as a function of temperature and pressure. An example for a single component phase diagram, as in not a mixture, is shown above. Phase diagrams also exist for mixtures, but these get very complicated very quickly.
What is radiation?
The emission of energy as an electromagnetic wave.
Why are snowflakes unique?
Excellent question. All snowflakes are made up of frozen water, ice, so why don't they look exactly the same? Their unique shape comes from the unique conditions under which each snowflake is made. As a tiny ice crystal is blown into and out of a cloud, or rises or falls in a jet of slightly warmer or colder air, the shape of the growing snowflake can change. In a sense, their shape describes a story of how they were made.
Why did Gerhard Herzberg, Canada, win the Nobel Prize for Chemistry?
For his contributions to the knowledge of electronic structure and geometry of molecules, particularly free radicals. Herzberg was a famous physicist and astrophysicist, and he was awarded the Nobel Prize in Chemistry for his great achievements in molecular spectroscopy. A particular demonstration of his skill in spectroscopy was his investigations into the role of free radicals in chemical reactions. Free radicals had long been a difficult target to study, owing to their relatively short lifetimes, on the order of millionths of a second. Herzberg's talent with spectroscopy allowed him to address this and other similarly challenging and interesting problems. Why did Christian B.
What herbal medicines do people still use today?
Aspirin and quinine are probably the most famous herbal medicines that have made the transition to mainstream medicine. Many modern medicines were originally isolated from plants. However, but the commercial sources are now usually man-made. For example, Taxol, R. paclitaxel, was originally isolated from the Pacific yew tree. In 1967 this compound was found to be useful as a treatment for various types of cancer. For almost 30 years, most of the paclitaxel that was given to patients was obtained from the yew tree. Alternate supplies of this drug were developed in the 1990s. Moving this natural drug into the realm of modern synthetic medicines.
What is smoke?
Smoke is a cloud of particles given off by a material that undergoes combustion. Its chemical composition will vary depending on what material is being burned. Smoke may consist of hydrocarbons, haloalkanes, hydrogen fluoride, hydrogen chloride, and a variety of sulfur-containing compounds, among others. These compounds can vary widely in their toxicity. So the severity of the health hazards associated with the smoke from a fire will depend on what is being burned.
What is aerogel?
Aerogels are materials that are very similar to normal gels, except for the key detail that the liquid component has been replaced with a gas. Since liquids were such a large component of gels by weight, aerogels are very lightweight. This type of material is translucent and has been given nicknames like solid smoke or solid air. It is produced by extracting the liquid component from a gel using a process called supercritical drying, which allows the liquid to be evaporated away without causing the solid network of chemical bonds to collapse. Aerogels have been produced from a variety of materials including alumina, silica, chromia, and tin dioxide.
Why does the sun glow?
The fusion processes happening near the core of the sun cause energy to be given off in the form of photons. See Physical and Theoretical Chemistry. The photons given off in the core of the sun collide with other atoms, which absorb photons and, in turn, give off additional photons. This process repeats, potentially millions of times, before photons at the surface of the sun are emitted off into space. As a side note, everything tends to emit radiation in this way. At least to an extent, it's just that most things on Earth are not nearly as hot as the sun. Even your own body releases electromagnetic radiation. But the photons coming from your body are in the infrared region of the spectrum, so we cannot see them with our eyes. However, Infrared cameras can use the photons given off by a person's body to locate people or animals, in this way.
What is the scientific notation?
A way of expressing a number is the product of a decimal and a power of 10, for example, 1050 equals 1.05 x 103.
What are chromosomes?
Chromosomes are a bundle of DNA and proteins packaged together. They are how your DNA is stored in your cells when it isn't being read by any enzymes. Each chromosome contains a large number of genes. Humans each have 46 chromosomes, all of which are present in each cell in the body. Chromosomes need to be unpacked by enzymes before their DNA can be read by RNA polymerase or other enzymes.
Why did George A. Allah, United States/Hungary, win the Nobel Prize for Chemistry?
For his contribution to carbocation chemistry. Carbocations are species that contain one or more positively charged carbon atoms. While these types of intermediates were postulated for years to play key roles in organic reactions, it was never believed that they could be isolated, due to the fact that they should be highly reactive. Allah managed to prepare stable carbocations through the use of extremely acidic compounds, which are actually called superacids. Allah's work thus revolutionized research into carbocation chemistry, as these species could finally be characterized for the first time. This work has been very influential in better understanding the role of these important intermediates in organic chemistry.
What pollutants are dangerous to the ozone layer?
The pollutants principally responsible for depletion of the ozone are volatile halogenated organic compounds. The most well-known among these are chlorofluorocarbons, CFCs, and hydrochlorofluorocarbons. HCFCs, which used to be used in virtually all air conditioning, refrigeration, and cooling systems. Another is methyl bromide, which is used commercially as an agricultural fumigant.
What is a phosphodiester bond?
Phosphodiester bonds are what make up the backbone of DNA and RNA molecules. These bonds provide the linkage that holds together the individual nucleotides or nucleosides in DNA and RNA. Enzymes called polymerases catalyze their formation, DNA polymerases for DNA and RNA polymerases for RNA. Take a look at the picture below to see the chemical structure of a phosphodiester bond.
What pollutants do coal power plants generate?
Burning coal introduces pollutants such as nitrogen oxides, sulfur dioxide, and mercury into the atmosphere. A large amount of carbon dioxide. The principal pollutant implicated in global warming is also produced by coal power plants. Aside from global warming, many of the pollutants from coal power plants are bad for human health and also cause smog, soot, and acid rain. The solid waste produced by burning coal can also be harmful to the environment. The ash from coal power plants is typically composed of about 5% pollutants or dangerous substances such as arsenic, cadmium, chromium, lead, and mercury. This can also cause pollution in water if it is not disposed of properly. And there have been many cases of water contamination caused by improper disposal of this ash.
Why do some fruits and vegetables turn brown after you cut them?
When you cut or drop an apple, potato, or other fruit, some cells leak their contents, exposing all sorts of cellular machinery to air. The key player in the browning of fruits is tyrosinase, an enzyme that is involved in the oxidation of tyrosine specifically and phenols in general. Tyrosinase plays two key roles in the production of melanin, which is a general term for all sorts of pigments found in plants and animals. So once tyrosinase leaks out of the cell, it is exposed to all the oxygen and phenols it needs to start making brown pigments.
Who ran the first chemistry experiment ever?
Jaber ibn Hayyan, known as Geber in Western texts, was probably the world's first alchemist to run actual experiments. Jaber lived during the 8th century in what is now Iran, and like alchemists before and after him, was fascinated by the prospect of changing one metal into another and by creating artificial life. To Aristotle's 4 elements, Jaber added sulfur and mercury, and proposed that all metals were made of differing ratios of these 2 elements. He was the first to emphasize the importance of rigorous experimentation, and is credited with describing many common lab techniques and equipment.
How can I extract iron from oatmeal or breakfast cereal?
Chemistry principles encountered in this experiment: magnetism, food chemistry / nutrients extraction materials you'll need: OATmeal XPERIMENT iron fortified instant oatmeal packet, check the label to ensure iron content. Magnet, it's easiest to see the iron if you can find a magnet that is coated or painted white or another light color. Plastic bag or bowl BRE fast CEREL XPERIMENT magnet for this experiment. You will want a magnet you can use to stir a liquid. It's easiest to see the iron if you can find a magnet that is coated or painted white or another light color. Plastic bag, water, large glass jar or beaker. The procedure: oatmeal XPERIMENT. Open the oatmeal packet and empty it into the plastic bag or bowl. Stir the oatmeal with the magnet. You should see small amounts of gray or brown metal collect on the outside of the magnet. This is iron. Iron is commonly added as a mineral supplement to breakfast cereals and other foods. Now you can see that the iron that goes into your diet is the same element that you find in objects made of iron metal, just in much smaller quantities and pieces. Recall that iron is attracted to magnets due to the fact that it is a ferromagnetic material. See atoms and molecules. BRE fast CEREL XPERIMENT. Pour 1 or 2 cups of breakfast cereal into a plastic bag. Crush the cereal inside the bag using your hands. Pour about 1 liter of water into the jar or beaker, and add the crushed cereal from the bag to the water. The water will help to extract the iron from the crushed cereal. Whereas the iron bits were looser in the dry oatmeal sample, they tend to be stuck within pieces of cereal. Which is why you need to mechanically crush the cereal and use the water to help extract it. The magnetic interaction wouldn't be strong enough to pull the iron out of the cereal on its own. In a chemistry lab, acids would often be used to help extract metals from a sample, but will work fine for our purposes here. Use the magnet to stir the crushed cereal for about 15 minutes. When you remove the magnet from the water, you should see iron filings collected on the magnet.
How many types of nucleotides are found in humans?
Nucleotides are named for the nitrogenous, nitrogen-containing base incorporated into the nucleotide, and there are only 5 types of bases used: adenine, guanine, cytosine, all found in both DNA and RNA, and thymine, DNA only, or uracil, RNA only. The corresponding nucleosides are called deoxyadenosine, DNA/adenosine, RNA, deoxyguanosine. DNA/guanosine, RNA, deoxycytidine, DNA/cytidine, RNA, deoxythymidine, DNA, and uridine, RNA. All of the genetic information in our body is stored in our DNA using sequences of only these 4 nucleotides. Imagine trying to describe how to make and operate an entire machine using only 4 letters. That's just what our genetic information does.
How does a microwave work?
Microwaves work by using a process called dielectric heating. The microwave surrounds your food in a field of electromagnetic radiation that is constantly changing directions. The polar molecules in your food, particularly water, align their dipoles with the direction of this applied field. The constant shifting of the direction of this field causes the polar molecules to tumble around. And this molecular motion warms your food.
What is para?
Term used to describe two substituents on an aromatic ring that are bonded to positions opposite to each other.
Anfinson, United States, win the Nobel Prize for Chemistry?
For his work on ribonuclease, especially concerning the connection between the amino acid sequence and the biologically active conformation, and Stanford Moore and William H. Stein, both United States, for their contribution to the understanding of the connection between chemical structure and catalytic activity of the active center of the ribonuclease molecule. Together, these three scientists uncovered the structure of the ribonuclease enzyme. And they were able to gain insight into how its structure related to its reactivity. In particular, Moore and Stein were able to correlate the structure of the enzyme's active site to its reactivity. Not only was ribonuclease an important enzyme to study, but their approach paved the way for similar studies to come.
What is the shape of a carbon-carbon double bond?
The geometry of the carbon atoms in double bonds is planar. This shape comes from the hybridization of the carbon atom, which is sp2, one p orbital is not involved in forming single bonds. To get a bonding interaction between these two remaining p orbitals, they have to overlap in space. So in a molecule like ethylene, C2H4, all of the hydrogen atoms are located in the same plane.
Do electrons, protons, and neutrons all have the same mass?
Protons, neutrons, and electrons each have different masses. Electrons are, by far, the lightest of the three, with a mass of only about 1/2000 th that of a proton or neutron. Protons and neutrons have similar masses, with that of the neutron being just slightly higher than that of the proton. The masses of the three particles in kilograms are: electron mass 9.1094 x 10 to 31 kilograms, proton mass 1.6726 x 10 to 27 kilograms, neutron mass 1749 x 10 to 27 kilograms.
Why did Ilya Prigozhin, Belgium, win the Nobel Prize for Chemistry?
For his contributions to non-equilibrium thermodynamics, particularly the theory of dissipative structures. Non-equilibrium thermodynamics is traditionally considered a particularly hard topic to address, because the assumptions one can usually make regarding the behavior of molecules are thrown out the window. Prigozhin's work expanded on existing thermodynamic theories to address systems far from equilibrium, such as when a liquid is heated rapidly from below. Prigozhin demonstrate that structures called dissipative structures could exist under conditions far from equilibrium, and that these structures could only exist in conjunction with the surrounding environment. Why did Peter D.
What is the rate constant?
A numerical value that characterizes the rate at which a chemical reaction takes place.